Hey guys, we're going to continue on our factoring journey here, and we are going to talk about my favorite factoring method, difference between squares. I love it because it's super quick and very simple, and the video will be no different. So let's dive right in, and we'll get on with this one in record time. Why difference between squares? So that we can simplify these binomials and understand the parts, the things that had to be multiplied together to get the binomial in a place. Just going to be good for us to know how to take binomials. We get down to the next unit, like rational. So get excited for that. It'll make sense when we get there. But now let's talk about when we use different squares. So there's 4 specific conditions that we met in order to use the difference between squares. The first is that you must have a polynomial. If your polynomial has 3 terms, 4 terms, 1 term, it's not going to work. It's got to be a binomial. Those 2 terms in the binomial must be separated with a subtraction sign. If you have a sign, it will not work. The sign is not a party. If you see a plus, you cannot use DBS. Your constant as an equation must be perfect square. It's called the difference between squares for a reason, folks. It's got perfect square. And then the exponents on your variable doesn't have to be a perfect, but it does have to be even. So if you have an odd number, it's not going to work. Let's take a little gander at some examples and don't make fun of handwriting, okay? I was using a program that's really hard to write. So x squared at 16 works because I've got a binomial, a subtraction sign, a perfect square, and an even exponent. X to the 8th minus y to the 6th. Once again, 2 terms, a subtraction sign, and 2 even exponents. And then last but not least, 25x to the 4th minus 1, 2 terms, a subtraction sign, perfect square, 5 and 1. 1. So 1 is a perfect square. 25 and 1 is 4. So that is an even number. All of those can be factored using difference between squares. So let's talk about these examples. X squared plus 15, x to the 9th minus y to the 6th, and 25x to the 4th minus 2. So go ahead and pause this video and fill out on your notes why these don't work for difference between squares. Right, for this first one, you told me, because it has a plus sign, cannot use difference between squares with a plus sign. For my example, I've got a binomial, I've got a subtraction sign, but I have a 9 as the exponent on my x value. And 9, while it is a perfect square, is an odd number, and that's not going to work for me. And then down here, 25x to the 4, yep, we've got a perfect with even exponent, we've got a subtraction sign, and we've got 2. And 2 is not a perfect square. For the use of a non-perfect square as the constant is throwing that third example off. Okay. How do we do this? Very quick. You make 2 sets of parentheses. You break up the first term. Take the square root and write it in the first place in each set of parentheses. Then you do the same thing to the second term. Square root it and put it in the second place of each parentheses. One set of parentheses gets a plus sign, one gets a minus sign. So let's see. I take x squared minus 16. I've got my 2 parentheses, and I put x and x in each one, because if we break up x squared, x times x. Okay, then we do the same thing for the 16. The square root of 16 is 4 and 4. It's called the difference between squares. So we are square rooting both of these terms. Okay, we're not dividing by 2. That wouldn't work. We've got a square root terms. So the square root of x squared and the square root of 16. Okay? One gets a minus and one gets a plus. And that's our answer. Factor x squared minus 16 using difference between squares gives the answer of x minus 4 and x plus 4. So your parentheses should match, with the exception of the sign. All right, let's try a couple of these. You've got these on your note sheet. Go ahead and pause the video and take a couple seconds to try these out, and then we'll go over the solutions. All right, so our first example was x squared minus 49. Square root of is x. Square root of 49 is 7. 1 gets a minus and 1 gets a plus. Then below that, we had a squared minus 1. Well, the square root of a squared is a. The square root of 1 is 1. 1 gets a minus. 16x squared minus 1. The square root of 6x squared is 4x, right? Because the square root is 4, and the square root of x squared is x. And then the square root of 21 is 11. It should come as a surprise that 1 gets a minus, 1 gets a plus. Let's not leave x squared minus 100, xy as the square root of x squared y squared, and 10 and 10, the square root of 100. 1 gets a minus and 1 gets a plus. All right, so it's a lesson. This is a really quick, easy method for factoring, especially because, 80% of the you're not even going to be able to use it and roll it out very quickly based on those 4 constraints that we lined up. Let me know if you have any questions, write them down on your notes, and we will be planning tomorrow to go over. All right, great job, guys.